Good morning, girls. uh, in the last class, we have seen a lot about, we have learned a lot of terms related to graphs because basically a tree is a type of a graph. So, before moving to or learning about trees, first we have to learn what a graph is, what are the or things constitute a graph or what basic terminology about graph. Okay, so different types of graphs, categories of graphs, that is what we have seen. Okay, so we have seen parallel address, multi graph, and next weighted graph, so an isolated vertex. So this is all we have seen in the SQS class. Today we are going to discuss about what a vertex and degree of a vertex is and how to consider it as a path. Okay, what is a loop, and connectivity, and tree, basic definition of tree, terms of the trees associated with the tree. This is what we are going to learn today. So the first thing here is degree of a vertex. So in a directed graph, so what is a directed graph according to our yesterday's discussion? A graph in which the direction of the edge is specified. If it is like see here we are representing the direction of the edge, that is it is from 2 to 1. So here it is specified to this arrow mark, so it is a directed graph. So if you don't specify any direction, then it is undirected graph. Okay, so in a directed graph, for any node V, the number of edges that V as its initial node is called the out degree of the node V. In other words, the number of edges incident from a node is its out degree, and the number of edges incident to it is an in degree or incoming degree. So let's see here. Say let's take this example. So for this A, there are two edges which are starting from this one. See, this is the this graph. You have vertices 1, 2, 3, 4, 5. So one vertex, from this vertex, or one is the initial edge. Starting point for two edges. See this one, 4, 1 to 4, and 1 to 5. For this edge, for these two edges, one is the starting point. So this is called out degree of this vertex 1. So what is the out degree of this vertex 1? It is 2 because it is the initial point for two edges, that is 1 to 4 and 1 to 5. So it is called the out degree. Incidence means it coming out. Okay, starting incidence, from there it is going to start, right? So next, the edges which are incident into, the edges which are starting from other points and coming to this particular vertex. Say from here, from 2 an edge is starting and ending at 1, and from 3 an edge is starting and ending at 1. So there are two edges which are ending to 1, which are mapped to 1, which are incident to 1. So here the in degree, this is called in degree. So the out ending point, terminal point is 1 here. So it is called in degree. So here the in degree is 2. Here out degree is 2 as well as in degree is 2, because two edges have starting point as 1. So those two edges are called out degree. And for two edges, the ending point is 1. So in these incidence point, edge is last edge, terminal edge is 1. So this is called the what you say, in degree of the point 1. So this is what we are saying here. See, the out degree is nothing but B as its initial node, the number of edges that have B as its initial node. So it has two edges. So that is called the out degree. In the same manner, the number of edges incident to it, the other from other vertex to it, So such kind of edges are counted as in degree, incoming degree or in degree. The sum of in degree and out degree is the total degree of a node. So this is what you have to keep in mind. Degree of a vertex is nothing but the sum of in degree and out degree together is called the degree of that vertex. If there isn't any direction specified, then the number of edges which are mapped to that particular, which are starting from that particular vertex is called as the degree of that particular vertex. So in a directed graph, you have to count both the in degree and out degree. If what is in degree, what is out degree, we have seen. If it is an undirected graph, say the total degree or degree of a node is the number of edges incident to the node. Incident in the sense that can be the starting or as the direction is not specified, you can't say that it is starting or ending to it. It is that edge is starting from here or an edge is coming to an end here. So in undirected graph, the number of edges which are incident to that particular node, there from that particular node, is called the degree of that particular node. For an isolated vertex, degree is 0. Yes, because in this case, this is the isolated vertex. There is no, you see, edge coming out or coming in into this vertex. So the isolated vertex degree is 0. The degree of a vertex A see, in this particular example, if you want to find out the degree, this is an undirected graph because no directions are specified. For this particular graph, if you want to find out the degree, what is the degree? Say, how many edges are starting from here? There from this, but not starting or ending. You can't say whether it is starting from A to B or from B to A. So you can't say it is starting and ending. How many edges are there from A to A? 1, 2, 3. So on the whole, 3 edges are there where A is the point, where A is included in that edge. So that degree is therefore specified as 3. Whereas the degree of F is 1 because only one particular edge is including F, a point F into it. So the degree of vertex F is 1. And the vertex 1 already we have seen here in this map. For vertex 1, the in degree is 2 and the out degree is also 2. So this is all about the degree of vertex. You have to, if as if at all equation comes on the degree of vertex, you have to specify in directed graph and in undirected graph how the degree is calculated. In directed graph, again you have to tell what is out degree and in degree, and the combination of these two will form the degree. Next, paths and circuits. So this is a little bit tricky to understand. Just try to understand paths and circuits. So what is a path and what is a circuit? So see, first thing, we are considering a graph G which is a set of two sets. One is V and one is E. So what is V? V is nothing but V is a set which includes all the vertices, and E is the set which includes all the edges. So in this graph, whatever edges are there, all those are included into this E set. See, E1, E2, E3, E4, E5, E6, E7. So on the whole, we have 7 edges and 4 vertices: A, B, C, D. We are not considering F. We will see why we didn't consider F, for what reason. Okay. See, an example of such a sequence is given by this. See, consider a sequence of edges of G such that the terminal node of any edge in the sequence is the initial node of the next edge. So consider the question. See the statement: sequence of edges of G. Okay. Terminal node of any edge, that means the end of any edge, is the initial node of next edge. So see, if you take the edge like A to B. So from again B, it has to give rise to another edge. So the terminal node of any edge in the sequence is the initial. So this is the initial sequence from B to C. So initial edge, initial node of the next edge. That sequence, for example, for that sequence is this: E1, E2, E4, E5. Let's see how is it correct or not. A to B, yes, condition satisfied. B to C, yes, condition satisfied. E4, C to D, yes, condition satisfied. And yes, E4, next E5, D to B. Yes, condition satisfied. Here again we are coming back to B, so it is closing the sequence. So see, terminal node of any edge in the sequence is the initial node of the next edge. So this condition is satisfied for this sequence of edges. So E1, E2, E4, E5. Next, you can also write another sequence. You can write a number of sequences. You can write this is what is we are going to do in trees. There are different types of traversals. If you understand this, you can understand that easily. So the sequence, another sequence that can be written is E1, E2, E4, E5. This can be also be represented as A, B, B, C, C, D, D to B. Yes. So you can list it in the form of vertex as a combination of vertices also. Next, and apart from this sequence, you can also generate another sequence: E6, E2, E1, E3, E4, E2, E5. See, let's see how this sequence is traversing. Taking place. E6, H6, A to C, C2, B, E2, B2, A, E1, A2, D, E3, D2, C, E4, C2, B, E2 again, and B2, D, E5. So this is another sequence. So this is how you can write a sequence, and just like how you traverse from one point to one vertex to the other vertex, whether you repeat the edge or won't repeat the edge. So here the edges, vertices are repeating. A, B is repeated in the last. Here they are repeated. Nodes are repeated more than once. So there is no condition that the nodes can appear once or more than once. Okay. So E6, E2, E1, E3, E5 is another sequence. All adjacent nodes appearing in a sequence need not be distinct. There is no rule that all the edges should be distinct. They can be repeated. So E2 is repeated, E2 is repeated twice, right? And the vertices are visited more than once. One vertex is visited. If you are moving from A to B, B to C, I call it a visit. From A, I'm visiting B. From B, I'm visiting C. From C, I'm visiting D. So the vertices are visited more than once. See this, the condition for a node to be in sequence, we call it as sequences. Each node appearing in the sequence must be adjacent to the nodes appearing just before and after it in the sequence, except for the first and the last nodes. So the condition here is the sequence is you can consider the traversal as a sequence when the adjacent a node must be adjacent to the nodes appearing just before and after it in the sequence. So they should be side by side to each other. They should be adjacent to each other to consider a node is adjacent to the other node. See, A sequence of edges of a graph such that the terminal node of any edge in the sequence is the initial node of the edge, if any, appearing next in the sequence defines the path of the graph. So what is the path? See, a sequence of edges of a graph. Sequence means traversing from one point to the other point east of edges, such that the terminal node of any edge, I mean the ending point of the edge, an edge will have 2 points, initial and end, terminal. So any edge in the sequence is the initial node of the edge. So the end point is the initial point to the edge appearing next in the sequence. Appearing next in the sequence, such a sequence is defined as the path of that graph. So path is nothing but the way you can travel in that graph. That say for example, you to reach our home or to reach a particular place like I take a railway station. If you Secunderabad railway station, so it is the center of, if we consider it a vertex, and if you take other vertices which are around that station, like from Amirpet, from Vekampet, and from Alwal, and from Habsikuda, so these are different 4 different points. To reach station, you have different. You can follow different paths, and until and unless they should be connected. So if you go into a path, if you travel through a lane where it is not connected to the, it doesn't lead to the path to reach to the station, then it is not considered as the path. So that is what we are saying here. Every edge should be a starting point to the other edge in the next sequence, then it is considered as the path of the graph. So the number of edges appearing in the path is called the length of the path. So what is path? This is first you try to understand what path is. A sequence of edges of a graph such that the terminal node of any edge in the sequence is the initial node of the edge appearing next in the sequence. So terminal edge should be the initial edge of the next uh, node in the sequence. Then it is called the path. And number of edges. So the total number of edges traversed to form that sequence or to go through that path is called the length of the path. So see here, P1 is equal to 2 comma 4. See here, P1 is equal to 2 comma 4 E2. So this is one simple short path. Next P2 is equal to 2 comma 3 3 comma 1 1 comma 4. So P2 we are taking another path as 2 comma 1. Okay. Next 1 2 3 3 comma 1. Next 1 comma 4. 2 to 1 1 to 3 to uh, 2 to 3, sorry, 2 to 3, 3 to 1, and 1 to 4. So this is one part, and it can be represented in the form of edges as E3, E4, sorry, E3, E6, and E5. Yes, next, another path P3 is this set of edges E1, E2. So you look through this edge and see this path whether it is correct. It is correct actually. You can traverse, take the edges both, which I mean takes this vertices and try to traverse through this path. So see, a path where no edges traverse more than once is called a simple path. So if this is the length of the path, the number of edges appearing in the path is called length, and where no vertex is repeated. No, I mean no edge is traversed more than once. I mean, the edge should not be repeated. It's called simple path. A path where no vertex is traversed more than once is called an elementary path. See, edge is not traversed once, it is called a simple path. no vertex is traversed more than once, it is called elementary path. Okay, so for example, in this E1, E2, E4, E5, E6 is a simple path, but not elementary, as the vertex 1 is traversed, visited twice. See here, what is the sequence? E1, E2, E4, E6, E5. E1, E2, E4, E6, E5. So here 1 is visited more than once. So it is a simple path, not an elementary path. So what is the condition for elementary path? The vertex should not be traversed more than once. So a path that originates and ends at the same node is called a cycle, circuit, loop, whatever it is called. So here, so this is a cycle. It originates there and ends there. So it is a circle or circuit. A cycle is elementary if each node is traversed once except origin, and if say is simple if every edge of the cycle is traversed once. See, a path that originates and ends at the same node is called a cycle, right? So this is a simple cycle. We will see another one, C2. This is also called a cycle. 1, 2, 2, 2, 4, E1, E2, E5. We will see that. E1, E2, E5. So this is closed, right? So that is the reason it is called circuit. A path that originates and ends at the same node. Yes, it is originating from one and it is ending at one, so it is called a cycle. A cycle is elementary if each node is traversed once except origin, and is simple if every edge of the cycle is traversed once. So a cycle can be called elementary if each node is traversed once except origin. Why? Because to complete the cycle again you have to return back to the vertex where you have started. So except origin, that is the condition. And it is also simple if every edge of the cycle is traversed only once. So if it is traversed only once, then it is called simple cycle as well as elementary cycle. So see here, cycle E2, E1, E2, E5 is both simple and elementary and is also referred to as closed path. E1, E2, E5. See, E1, E2, E5. It is elementary. The origin is registered only once, and the edges are traversed only once. So except origin. So that is the reason it is called. It is both simple and elementary. And it is closed path. It's not um, diversifying, it is closed. So this is about your paths and circuits. So cycle or circuit are one and the same. See why, if you understand this cycle, then we can move on to what a tree is. So next, connectivity. So what is connectivity? A graph is said to be connected if and only if there exists a path between every pair of vertices. So between every pair of vertices, if there is a edge or a pair or a path, then it is said to be a connected graph. So if at this it is two connected components, this is one different component and this is one different component, but here it is called a connected graph because these two components are connected through one component, one edge. So this is example for connected graph. So this can be considered a different graph and this can be considered a different graph, but these two, in order to get considered as a connected graph, there should be existing a edge between these two components, connected components. This is a disconnected graph and this is a connected. A cyclic. So what is a cyclic? A simple graph that does not have any cycles is called a cyclic graph. Such graphs do not have any loops. So this is the basic definition for tree. A simple graph that does not have any cycles. Closed parts like this. This is cycle. E1, E1, E2, E5. So this is for a closed path. There should not be any cycle in that graph. Such graph is called a cyclic. So a simple graph that does not have any cycles is called a cyclic graph. Such graphs do not have any loops. If it doesn't have a loop, then it is not a cyclic graph. So it is called a cyclic graph. And see here, what is a tree? A class of graphs that is acyclic is termed as tree. So a tree is nothing but a cyclic graph. A cyclic in the sense there are no cycles, closed loops in the graph. So such a graph is called a tree. So now from graphs we have come to what a tree is. So this is graphs. Trees are a part of the graphs, right? So what trees are and what are the terms associated with trees and how you can draw a tree, how you can traverse. So this is we will see in the next class. So if you have any doubts in this class, do message me in the group. Take care. Bye.